All right, good evening, everyone. Welcome to the live chat. Of course, the primary discussion for tonight will be on the winter forecast, which should be pretty interesting to see how that plays out in terms of the actual results. Now, I know that a lot of you have a lot of questions, and wow, there is a lot of you already in the chat rooms here, and so this is how it's going to work. I'm going to discuss the overall theme of the winter forecast. Specifically, I want to touch on, and I already saw this because today's almost like winter forecast day. The National Weather Service had it out, AccuWeather, a couple other places, okay? And what I want to do is explain why I very much stayed away from your typical La Nina characteristics in terms of the forecast. Now, I know there's a triple dip La Nina, okay, which is very rare on itself, okay. The thing is that this La Nina is different from any other La Nina that you have in a triple dip era. And every one of the other triple dip errors, God, I'm doing good tonight. It had the following characteristics, and it would help if I actually had the map up there. There we go. Okay, so every single one of them had basically a negative PDO, and with that negative PDO, it enhanced the La Nina, and about half of them were central, and the other half were east base. So in terms of the orientation, sure, you have east base in place. That's clearly already established here. But none of them had a positive PDO, which is what we have essentially started to develop here. Okay, you got the colder water here. It's not textbook, but it's enough to make clearly you have warm water along the west coast here. You have some coolish water here and under the influence of La Nina, and a clear east-based La Nina in place. That's pretty much textbook in terms of the east-based orientation. But that factor alone says you must move away from any type of typical La Nina signal and look at the comparisons between a positive PDO and a east-based La Nina, which is why in the forecast, which you could read as a premium member, it's about a 30-page book on the winter forecast. But the years I picked out, I'm scrolling down to visit that, so I do apologize. Here we are, for scrolling. The years that matched this type of configuration since 1900 is 1908-09, 1938-39, 1984 and 85, 1995-96, yes, I know, and 2005-2006. Of those years, only 1995-96 had a weak polar vortex. Every one of those years, when you compare it to the climatology of that time period, and I say that because you can't really use the same climatological averages for now in terms of how much snowfall we get annually to 1908, 1909, 1938, 1939. It's not exactly the right ballpark, okay? But every single one of them in their climatological eras either featured near to above normal snowfall. Now, before everyone focuses in on 95-96, look, I know everyone's going to really focus on that, but understand, as I said last year, 1995-96 was the fantasy dream of snow lovers and the nightmare of snow haters, because literally every aspect of the atmosphere combined to develop a perfect weather pattern for snowfall. Every single one, okay? It was one of the most amazing years I've ever seen, and I was, I'm dating myself now. I was in middle school at the time, and I was enthralled with what was going on, right? And I didn't really understand it until I went back when I went to college and I actually did research on that time period. And the perfection of the pattern and the ability for every storm to feed back on the other is something that we might not ever see again in a very long time. So yes, 95, 96 is in the years in which we count, but I would not use that as the hallmark. That's like if everything worked out perfectly, okay? But every one of these years noted either had near to above normal snowfall for the time period in which it happened. The only problem here is that this is not a typical year. And of course, we scroll back up to our volcano. In this discussion, I went into great detail on the impacts that, and I'm going to screw up this name, Hunga eruption. Okay, if I mispronounce that wrong to anyone who actually knows how to pronounce that correctly, I do apologize. But look, to be fair, I already butchered the English language more than enough, so trying to do another language would likely lead to a disaster anyway. Anyway, exactly. The reason why this volcano is so unusual is because it injected water vapor into the stratosphere. How much water vapor? This chart from NASA shows us what our normal baseline is, around 1,550 SWV, okay? That's the total mass, okay? That's your water vapor, saturated water vapor. So here you have your water vapor locked in, right? This is what we normally have. It fluctuates here and there, but you get the idea, right? This is now the current state, roughly 10%. But what a lot of people are making an error in is assume that this 10% is equally distributed throughout the entire atmosphere. And it is not. You see, when we take a look at this study here, now here's where the volcano happened, and this is the water vapor. The majority of the water vapor is trapped along and south of the equator. And 9 months in, it has not moved much towards the northern hemisphere. And the way that we track this is very simple, okay? I'm going to simplify this so that you don't need to worry about, hey, do we have enough water vapor data and all that stuff, okay? It's very simple. When you put water vapor into the stratosphere, what you do is you cause massive cooling. So if you know what the impacts are of the water vapor on the stratospheric environment, then you know where you're getting your impacts from. So then what we do is we go to, let's see, my stratospheric data, which I had somewhere around here. Oh, well, I'll just pull it up. So we go to stratospheric data. It's probably one of the last things that didn't pull up, but that's okay. Okay, perfect. So you go to cpc.ncep.noaa.gov. Again, completely free. All right. And you go to Stratosphere Global Temperature Time Series. And then from here, you can take a look at the entire stratosphere, and you could study the different layers. Now, first we'll go to the southern hemisphere, mid-latitude. That's 25 south to 65 south. Think of it like Central South America, portions of Australia, India, those locations, okay? You see at 30 millibars, look at this rapid cooling. It is historically cold. It is frigid, okay? This is at 30 millibars, at 50 millibars. Well below normal. So we see, I just wanted to show you first the baseline of what happens when water vapor impacts the stratosphere. And the reason why this is important, and some sources picked up on this, is that when you have this water vapor thrown into the stratosphere, it doesn't cause warming, it causes rapid cooling. Now, the rapid cooling in the stratosphere causes contraction of the stratospheric layer. Now, when that happens, the troposphere where we live expands. And when the troposphere expands, we warm up. So that's why you may have seen throughout various news sources that the introduction of water vapor causes significant warming, which it does. The only problem is that we're not seeing that impact, at least right now, for the rest of the of the stratospheric level. So, for example, if we go to the mid latitudes to the north of the equator, it's above normal. If we go to the mid latitudes here we go. We are slightly below normal, but pretty much within the climatological expectations you would expect. It's not historically low. It's just pretty much textbook. It's almost the same as what we saw last year. Nothing that really stood out. Then the higher latitudes, well, we were above normal, and now we're near normal. So the point is that the introduction of water vapor is not really influencing the stratospheric environment at the northern hemisphere directly. But we have to consider a couple of things here. Okay, now let's think about this for a minute and sit back for a minute and think about the forecast for the tropics. Now, what were we expecting? An active year, very active year, well above normal. We're talking about historic hurricane activity with multiple major hurricanes and possibly the most active year we may have ever experienced. Why? Because La Nina was going to be in place, shear was going to be low, waters were warm, game on, right? Let's think about that. Why am I bringing that up? Is it because I want to gloat? No, because my forecast bombed just like everyone else. Is it because it's a clue? Well, if we had a moderate La Nina, and I think we can all agree that this is a moderate La Nina, based on the data here. I mean, look at the data from the SOI. This is definitely a moderate state La Nina. Okay, so definitely moderate state La Nina. All agreement on that. But it's not acting like a La Nina. Take a look at the jet stream here. Look at the subtropical jet stream. This baby is rocking and rolling. So this is not acting like a La Nina. What is happening? Well, let's take a look at something else. Let's see. I'm going to pull up some special charts. And we look at angular momentum. And notice our angular momentum has been trending towards a positive state. This is a La Nina state. This is a El Nino state. It's been going all summer positive, negative, positive, negative, positive again, and even strongly so. It was generally right around here. Then it took a nice dip and then shot right back up now. So what would cause that? Well, we know we have instability in the atmosphere, a disruption in the mass balance of the atmosphere, which has to influence the circulation of the atmosphere, because the Earth is always looking for a balance when there is an imbalance. And ladies and gentlemen, this is one heck of an imbalance. So what I think is happening, and again, this is just a theory, because we have never, ever recorded this type of scenario happening, and we don't have any other type of data to look back on to say, okay, this is what's happened. And those that have modeled it have had so many different solutions that it's just complete chaos. So sometimes you have to sit back, look what's actually happening, and say, okay, what are we actually looking at? So what I did is I went back and I basically sat here for a couple days and I stared at the stratosphere. I looked at how the polar vortex was trying to develop at 70 millibars, and you could look at 10 millibars. And I looked at the interaction between the southern hemisphere and the northern hemisphere. And you're seeing this warping taking place. Even though the polar vortex is strengthened a bit, which you would expect at some point this time of year, even though it started off pretty weakly. What I think is happening is that the influences of the volcano has caused a displacement of mass such that it is interrupting the natural circulation of the polar vortex in order to create a balance with what's going on in the southern hemisphere. That evolution in the atmosphere is going to continue to influence the rising and sinking of air between the troposphere and the stratosphere. I think that is why we saw a disruption in your typical La Nina pattern, because that balance is causing an enhancement of the subtropical jet stream. So you see this here trying to create a balance between all the moisture here, and you start to see that interaction here in this cell. And so we work our way down to 250 millibars, and you see that same interaction, and you see the enhancement as a result of our subtropical jet stream. So despite the La Nina conditions, you ended up with a stronger subtropical jet stream. With the stronger subtropical jet stream, it led to a increased shear anomaly and unfavorable MJO forcing for the tropical Atlantic, which in turn produced an environment where you had a strong high pressure system around Africa, which drove dust into the Atlantic, which increased shear throughout the Atlantic, and basically turned this La Nina season into an El Nino-like season. Flipped it on its head. So considering the fact we are not seeing any change in this environment, and that we have a condition set up for a weak polar vortex already in place, with increase of what we call the EPV flux, okay, which is basically, I'll make this as basic as possible, okay. This is a parcel. This parcel usually stays in the troposphere, but when it gets lifted up and interacts with the stratosphere, it causes warming and disruption because you're displacing mass. So that is being enhanced, and we're already seeing that. So what I basically did is take a look at the environment we have now. Threw out your typical La Nina forecast and started from scratch to what is actually setting up in the oceans. How do those thermal gradients interact with each other? How does that interact with the development of the polar vortex? And what is the base state of the stratospheric environment based on the influence on the volcanoes? And that's how I came to this forecast. Now, what can go wrong in this forecast? I wanted to bring that up because that's very important. And I'll just say, I don't even need to scroll down to it. Okay, it's basically this. If I'm wrong about this whole mass balance idea, then yeah, the forecast could bust. Okay? Of course, given what we've seen so far, I feel pretty good about it. I even did the calculations, but I'll spare you the calculus. But I feel good about it. But if that goes wrong, then fine. And we'll know if it goes wrong if we see massive cooling taking place at 30 millibars. So again, if we see this chart and you see this red line here, if it drops down here, then my forecast is toast. If it stays right around here and every so often bumps up into here, I'm golden. But if it crashes and burns and drops down to here, much like what we saw in the southern hemisphere, then my forecast is done. Okay, so that's the first key. The other key is that if the La Nina that we have in place shifts towards a central base and the northern Pacific, let me just pull this up, if this goes rapidly cold all of a sudden and this shifts to here, then the forecast is shot, because that would lead to a predominant positive NAO pattern and we'd miss out on everything. And of course, another thing that could mess it up is another volcano, but we're not going to go there. But that is basically what I'm seeing here. Now, there's other aspects which I'm sure I'm going to get questions on, like the Siberian snowfall and all that good stuff. And I will definitely answer every one of your questions. They're really piling up in here in YouTube and also in the premium chat. So I'm definitely going to be answering every one of your questions, and definitely pile them in and send them in, because I'll be happy to answer every single one of them. But this pattern that I foresee in the winter is one that is almost like a hybrid of a La Nina and El Nino. And it will be controlled by the state of the EPO. So I set this up in the public part and the premium part, so I don't feel bad about sharing this aspect about it. So let me just go to the public forecast right there. Isn't this a cool picture? I love this. It's like nice dark and snow covered. It's really cool. Okay, so we start off with the positive EPO combinations. This is when the when the trough in the Pacific is in the Gulf of Alaska. That leads to a situation where you have storm tracks coming into the west coast, and the trough axis is such that any interaction between a subtropical jet stream will basically send a storm up towards the central and eastern Great Lakes. This little red line here, this is a situation where we have a negative NAO still kind of lingering, and you get like one of those waves of low pressure on the warm front, and you kind of get this icy mess. So that is what that is. But notice how thin it is. This means that your primary is back here and your secondary is here. So you might start off as like a snow, sleet, changing over to rain on the coast, and just a wintry mess over the interior, stuff like that. This is your Arctic jet stream, which sometimes is going to drop south, but in this scenario will be pretty much focused over the northern plains. This is kind of like your Alberta Clippers and stuff like that. So this could produce a nice little lake effect snow event over the western Great Lakes. But you can see the whole theme here is that you have a ridge here and you have your trough here, very much La Nina-like. Okay? In a positive NAO, positive EPO, sorry, that was a positive EPO, positive NAO environment. In a positive EPO and negative NAO environment, you have the same scenario of storms lifting up towards the Great Lakes, but then you have the potential for redevelopment. And instead, again, still kind of a wintry mix along the coast, icy mix and snow over the interior, and your Arctic jet stream, your Arctic shortwaves are very progressive. Okay? Negative EPO situation. We'll start off first with our favorite negative EPO, negative NAO environment. That's where you have your Arctic shortwaves, your polar shortwaves, and your subtropical shortwaves, all possibly creating either a phase, possibly even a triple phase. You get your Alberta Clippers. You can get your redevelopment along the coast. With this is going to be your best potential for snowfall events. Okay? The question in terms of how much snow we get this year will basically come down to how many times will we get this combination. Because we'll see all four combinations this year. It's just a matter of which one do we see more frequently. And that'll pretty much be the name of the winter. I suspect we'll see more negative EPO patterns than anything else. Then the question comes down to the NAO and the fine details within that. And then finally we have our negative EPO, positive NAO environment. That's where you get your storms phasing over the south and then heading right out into the Atlantic. So this would be a good environment for snowfall for Washington, D.C., Virginia, North Carolina, scaring the heck out of Georgia. Georgia shuts down with the 2-inch snowfall. And you get a lot of your Alberta Clippers rapidly marching their way through. This is actually a very cold, dry weather pattern for the northeastern United States and the northern mid-Atlantic, and a very stormy one for the southern mid-Atlantic and the southeast. So of these, the only one which features a real predominant mild weather pattern will be the positive EPO, positive NAO pattern, which I think this one is going to be the rarest one of the four. Okay? And the reason why I think that is because we have below normal sea ice values, we have a trend towards near to slightly above normal snowfall in Siberia. I think that's going to be slightly above normal. I'm not counting on that being the primary influence on the polar vortex this year. I suspect what will be two things. One, the state of the below normal sea ice, and two, the influence of the volcano combined with the state of the Pacific, in which this environment has led to numerous negative NAO environments because of the transport of air masses from the troposphere to the stratosphere as it marches from the eastern United States towards Scandinavia and lifts up into the atmosphere. This is a typical environment for a transport. Also, the waters in the Atlantic, by the way, I don't want to pass that up, would be supportive for a feedback process. It doesn't cause it, but it supports a feedback to support a predominant negative NAO environment. So what I mean by that is that first you need to get the stratospheric conditions in place, and you have to get the pattern to lock in first. But then once it locks in, these sea surface temperature anomalies set up the potential for a feedback process in the Atlantic. Now, one thing that is a bit unusual, and I want to touch on this, is that the expansion of this warm water pool is one of the largest I've seen so far. Typically what you want to see is below normal water here and below normal water here. It's only near to slightly below normal and near to slightly above normal here. But this is so much above normal that it creates the thermal gradient to set up the environment for a negative NAO feedback to develop. So I'm more looking at the thermal gradient than the actual anomalies in that environment. So that's pretty much it. I worked a lot on the details, and I know people want to know like how much snow in my backyard and all that stuff. I don't know how much snow is going to fall in your backyard. Okay, but I do know that the environment is such that I think that if you are going to do a copy-paste La Nina forecast, I think you're going to be in trouble based on what I'm seeing here. So what I'm going to do, wow, there's a lot of good questions out there, so I'm going to take them up and answer them right now. And again, while I'm answering them, if you have more questions, just shoot them out there. I'll be happy to answer them. Let's see, card. Let's see, first says, I can't recall seeing the 250 millibar polar and subtropical jet streams as amplified at this same time before. And let me pull up what he means by that. Make sure. Okay. So this is one amplified jet stream couplet. Okay. In a El Nino, what happens is that this feature weakens and this feature strengthens. In a La Nina, it's the other way around. The polar jet stream is very strong and the subtropical jet stream is very weak. What we have in place in reality is, and we could just look at the winds here, they're pretty much on par. You have your cutoff upper level lows in the subtropical jet stream. You have some interaction between the polar and subtropical jet streams. And this is something that is very key and actually is a factor for this upcoming weekend. The timing and the potential for phasing between the subtropical and polar jet streams is going to be a major story this winter. And how short waves phase together will be a major factor in determining who gets what in a winter storm. So that's another feature that's going to enhance even more volatility in the forecast, because you're talking about the interaction of 2, possibly 3 short waves in a single storm. which typically is what you see in an El Nino year, or in a very weak El Nino year or a neutral year, and something that can at times introduce an Arctic shortwave, which is poorly sampled, that can create all sorts of havoc. So this whole jet stream couplet that we're looking at here right now just gave me a whole bunch of warning signs when I started this forecast, because this is not atypical. Snowball says, "Let's go, big winter incoming." Well, we'll see. Let's see. I suspect you will be correct that those who forecast it's La Nina, therefore this is going to be off big time. Look, they could be right. With so much volatility in the forecast, it would be improper for me to say anyone who's going to do that will be 100% wrong. I just think that given what we're seeing so far, I don't know how you could say typical La Nina, because that forecast did not work out for the summer. It didn't work out for the tropical forecast. It hasn't worked out for the fall. In fact, this is kind of like the first fall in like a decade where it actually felt like fall. Like, have you guys noticed that? We didn't go from summer to it's freezing out. We've gone to summer to it feels cool, and we get it a little bit chilly. But not like a rapid drop. You know what I mean? It hasn't been that drop and crash. I can't recall ever seeing such an active and robust subtropical jet stream. That's true. Good evening, Robert. Really like the write-up being a PDF document. So much easier to read. Yeah, I decided to do that just for several reasons. One, because it puts less drain on the website. And two, because then I could save it more easily. So, let's see here. Oh, this is a good question. Did the cold stratospheric air from the water vapor displace warmer air that got pushed into areas away from the water vapor, helping the warm air transport towards the poles? I haven't seen that yet. The way I'm handling the water vapor, let me have a sip of my coffee. Okay. So, the water vapor introduction was kind of like if you took a warm shower and then you introduced cool air, the warm air from the shower didn't move someplace else. It rapidly cooled because the introduction of the dry, cool air, right? In this case, you have a dry, cold environment and you throw moisture into it, and that caused rapid cooling in the stratospheric level. It also caused an increase of cloud cover in the stratosphere, which enhanced that warming factor. So you didn't see a transport of air that was in the stratosphere away. You just saw this development of a cold pool. So basically, it'd be like if you took a wet towel and you have this wet, damp towel in a stratospheric environment and you drop it in the middle. That area cooled, but the rest of the surrounding area that wasn't impacted really didn't have a major advection aspect. What you did create, though, was a significant thermal gradient and density gradient in the atmosphere, which I think is what's causing a lot of the havoc that we're seeing right now. Looks like during the eastern warm-up, the Rockies and west central Canada are going to get a couple decent snowfalls. That would be kind of the idea. This should be a very interesting weather pattern in that transition, because what that will do is that when we see that pattern setting up with a trough in the west, it's actually going to build up the snowpack here over northwestern Canada. And you're going to watch as that buildup takes place, you're going to see Arctic air masses really intensify. And then when we shift back to a negative EPO, which is basically a trough right around the Aleutians, it's going to take that building Arctic air mass with that fresh snowpack and drive it right into the eastern United States. So one feature, one warm pattern in the east will actually set up the next cold weather pattern because of the enhancement of the polar and Arctic air masses in northwestern and central Canada. Or I could be wrong. Notice I'm taking a very non-confident stance in this. It is my job to be completely honest with you. This is likely one of the most difficult forecasts I've ever had to do because I really didn't have anything to compare this weather pattern to. There's a lot of people that rely on teleconnections. Now, I've heard some things floating out there like 2010, 2011. But the problem is that none of those years were like this one. Now, I did take those 5 years that I was talking about from a tropical forcing basis. And the reason why I did that is because I wanted to at least narrow down something in this environment to 5 years. And take those 5 years and then say, okay, now let's take this environment and then disrupt the natural stratospheric circulation. And what would that look like? And unfortunately, I don't have, a bank of computers to create insane models. So what I did, the reason why it's been taking me so long, I've been working on this since August, is that I took actual equations and worked the equations out because I'm sick in the head. And besides, I used to like calculus, so, I figured I'd give it a shot. And I am 100% on board with the idea that this idea could be completely bonkers, that my calculations could be way off. So that's why I started that off in saying that, in that I want you to be prepared for what I think is going to be an active winter, but understand the volatility in this forecast, in every forecast this year, is so manic and likely will be for the next 3 or 4 years because we have never dealt with this type of volcanic influence before. If this was a straight volcano on land, shoots up the ash, blah, 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 not a problem. I have at least 10 cases that are like that. I can find a La Nina with it. I can mix it up, see what it was like, make a little shift here and there with the PDO. Boom, bang, done. I don't have anything like that right now. At all. Anywhere. And neither does anyone else. So when you do that, you have to think outside the box and kind of see, okay, what else could actually happen? And yes, lots of coffee. So for this winter, stock up on coffee. Yeah, I have. That's for sure. Doing all the equations is old school forecasting. It's what I learned heck, I'm not that old, but it's what I learned in college. Okay, so it was 20 years ago. But still, it's the stuff I learned in college. Basic. Dr. Scubis in Oswego, he's still there. Crazy guy. You talk about math, that guy literally gets excited about math. It's hilarious. He just gets all giddy and starts jumping around the classroom and stuff. It's a wild sight. At least when I was a freshman. When I was a junior at the time, and he just started. Weirdest thing I ever saw. But the man taught me why it was important to understand these mathematical equations. And I think because of him, I'm a better meteorologist. So I just wanted to say that. Even though at the time I thought he was nuts. And I hated math because of it. Because of him, I became a better meteorologist. Okay, so Dr. Scubis, if you're listening, or if you have any students that are listening, thank you. Because great guy. So let me check out YouTube and see what questions we have here. Wow, we have 40. Wow. Okay. Will our first major snow event happen come December or January? It's a good question. Okay. Typically, climatologically speaking, you rarely see a snowfall before December 15th. It can happen. I'm not saying it doesn't happen, but it's more difficult, especially for the coastal plain, because of the sea surface temperatures causing a warming of the troposphere and the boundary layers. So what you would end up with a typical snow event, instead of like, where you're 29, 30, you end up 33, 34, and that leads to like a wet snow or a rain event, very cold rain event. So I would say that our first snowfall event has the potential of happening between December 15th and the end of the month. Okay, so mid to late December. Of course, there's always going to be caveats, but that's when I think your potential starts to increase in terms of your first major snow event. This year, in terms of a La Nina influence, I think that it will start off fast for mid-December, January. Then we'll probably get a little break around mid to late January, and then rocking and rolling again late January to February, like around the Super Bowl time. And then we'll see, depending on the fact that La Nina is weakening, we could get one more shot in like early March, like late February, early March, right around that time period, depending on how La Nina collapses towards the end. And like literally every model has it collapsing. So it should be interesting to see how that plays out. This is also one of the best foliage seasons I've seen with our cooler start to October. Absolutely. I agree 100%. Are there any effects on the atmosphere from the methane that was released from the Nord Stream pipeline? That is an excellent question. It has a small impact on the region in which it happened over Scandinavia. And that is going to be very interesting evolution, because you get that methane getting into the upper troposphere and lower stratosphere, okay? That component leads to warming, but I'm not sure whether it was enough to have an impact. Now, the reason why that it's important as far as the location is that typically if you have warming around the Scandinavian nations, okay, this leads to a Scandinavian ridge. Scandinavian ridges tend to help to disrupt the polar vortex. But based on what I've seen, I haven't seen enough introduction of methane, at least not yet, to say definitively that there would be an impact. But if that continues to happen, methane is a very powerful warming agent. Very powerful. So if we keep on putting that up in the atmosphere, forget CO2. CO2 is a 2-pound wimp compared to methane. Methane is like Arnold Schwarzenegger on steroids after someone insulted his wife or girlfriend, or whatever he's doing right now. Okay? Is a very volatile, angry agent that you do not want to put a lot of into the atmosphere. You think warming is bad with CO2? Try methane. That is a very powerful greenhouse gas. And if we put a lot in it, that creates warming. There's no debate about that. Just look at the calculations in terms of the methane molecule and how it impacts thermal reduction. So, if that continues to happen, it could be a very interesting impact, but I don't have enough data to be definitive on it. So I want to be clear about that, but something I'm going to be keeping an eye on. Great question. The leaves have been pretty good. Surprised because we had such a dry summer. Yeah, I would agree. I did not expect the foliage to be as beautiful as it has been. Would our cooler October play a part on the winter forecast? There has been some data to suggest, some, I guess you call it statistical data, to suggest that there is an interaction between the nature of October in terms of temperature and what our winter will be. And the problem with these statistical analysis is that they show this correlation, but they don't do a good job of showing causation in terms of what is the physical properties that would cause that type of forecast. And yeah. And what I would say is that when you have a cool October, what typically causes that cool October is a repetitive negative NAO pattern. And let me pull up the NAO here. Okay. For October, we have been waffling between negative and positive all month. It's going to average out to be pretty much a positive year. In fact, let me pull up, let's see here, if I can pull up the SPC data on ENSNO. In 1 second, I'm going to find it. NAO. Because I think it should be, there we go. That's what I was looking for. Okay, so for much of October, we've been bouncing around positive, negative, positive, negative. We got a nice negative shot here, and we go back to positive. So on average, we're talking about a slightly positive NAO pattern. When we had that correlation, it was sustained negative NAO pattern, which then translated to a positive NAO in the winter. And that has a lot to do with snow growth factors in Siberia and the state of the polar vortex and all that other stuff. But if the causation doesn't match with the correlation, then you really can't use it. Excuse me. So I would say that the cool October weather pattern is a sign of how strong the polar air masses are, more than any correlation to what pattern we could expect and how that impacts the winter. When will we see some snowflakes in northwestern New Jersey? Climatologically, usually it's sometime between December 5th and December 15th. Let's see here. I have never heard of someone not in college and doing calculus for a winter forecast. Well, what can I say? I'm a pretty weird dude. After the warm stretch, when we revert back to cold, do you anticipate possible strong front, strong storms as part of the change? Definitely strong cold fronts, absolutely. I don't see a return of severe weather, but I definitely like the idea of powerful cold fronts and very strong cold air transport regimes. Methane may not be the biggest disruptor they put into the air in the world, in that part of the world, unfortunately. Yeah, unfortunately, but hopefully that doesn't. Let's just say that hopefully smarter minds will prevail and we won't have war, right? or more war, or whatever. Just people need to get along. That's all I could say. Let's see. So far, we're doing pretty good with the questions. Well, it's almost 9 o'clock already. So, if anyone has any questions about the weather pattern overall, definitely let me know. While we have a little bit of a break in the questions, I just want to touch on the environment for our potential storm setting up for this weekend. And here's our water vapor satellite picture. And here's what I find interesting, is that we have our upper level low. It's starting to pull out, and you're starting to see signs of that short wave here starting to drop south and having the potential to cut off. What's interesting is the interaction here between these two features. And the reason why I find this interesting is, again, it goes back to the winter forecast of the ability of short waves to cut off and then get forced up the coast, because we continue to have this ridge out here in the Atlantic. And the thermal gradient interaction here to support that moisture transport is very interesting in terms of the support of it developing. Now, with that being the case, I was skeptical of this scenario initially only because I was looking at the way that this whole scenario was evolving and saying, okay, this is going to be the first real test of this environment in terms of the ability for the polar jet stream, the subtropical jet stream to interact, and for cutoff lows to develop. And what models handle this best in this cold season weather pattern? And because we are in the cold season. So I wanted to keep an open mind to the GFS ensembles, the European ensembles, the Canadian and the European. I didn't just want to go, European saying it, let's go for it, right? Because I wanted to give the other models a chance to say, hey, look, we're in this game too. And it appears the European is pretty much going to be rocking this out. Now, the European was a little bit too strong initially, but it basically has the right idea. And this is a very important signal for me because the European guidance gets its data. This is all about data collection, guys. You can all this talk about, oh, we make the best models, garbage. What's important is data. Good data in creates good models out. Okay? Bad data or limited data creates limited solutions. So the European way of ingesting data is better than NOAA's way. NOAA's great. Don't get me wrong. I love NOAA. But the fact of the matter is that the difference is how they disseminate that data and put it into the model guidance. And so with that, we had our first real test run, and it looks like we're seeing that that really play out nicely with our weather pattern. So I'm going to get back to your questions in a minute, but I figured let me touch on this while I have a second. There is our feature. Let me zoom this out so that we can see a little better. There is our feature lifting up. And because of that interaction, our subtropical jet stream here is going to be capable of sending moisture right into the coastal plain Sunday evening into Monday. So I'm not looking at this being a major rainfall event, but basically scattered showers Sunday afternoon all the way on through Monday. Some heavier downpours, a few locations may push over into rain. But it's certainly something to monitor in terms of how well the models are handling this type of scenario. This has been the most normal, nice October fall in a very long time. We are running 5 degrees below normal for the month in the Lehigh Valley so far. Absolutely. Let's see. We got some more questions here on YouTube. Can you tell me why winter weather on the East Coast seems so much harder? I could be wrong. As my math teacher once said, garbage in, garbage out. Exactly. Okay, in terms of forecasting or the weather pattern overall. So I'll do both. In terms of the weather pattern overall, the East Coast, and here, let me zoom out here and use a water vapor. Here, perfect. Okay. The East Coast is a very unique environment in the world. In terms of you have the ability to interact with at least 4 or 5 different air masses coming from the Arctic, the polar regions, the Gulf of Mexico, tropical Pacific, and the Atlantic, and also tropical Atlantic. So let's see, 1, 2, 3, 4, 5, 6. 6 different air mass sources, which is kind of unique in the world. And when you have that type of different interaction of air masses, you can create different moisture interactions and different density interactions, which leads to different short waves interacting at different speeds, which creates a very difficult forecast. And it also leads to a higher potential for very powerful storms. The East Coast also is unique in that we have a Gulf Stream that basically is a warm nitroglycerin factory for storms. So you have this warm water marching up. You have Arctic air or polar air diving south towards that warm water. You get basically, this is just gasoline waiting for a match. And so that's why you get a very, very impressive, powerful potential storm in this type of scenario. In terms of forecasting, what makes it very difficult to forecast here is that, first of all, we've been talking about all synoptic levels. We haven't even talked about mesoscale and microscale, as in the influence of urban heat islands and how that creates snow bands and mesoscale banding within storms, which could lead to one area getting 5 inches of snow and the town over getting 15 to 20 inches of snow because a band of snow at 2 inches per hour sat over that one location, didn't sit under another, which creates a whole bunch of volatility just on that alone. And then we didn't even talk about the coastal front that can make the difference between you getting a heavy snowfall at 32 degrees or a wintry mixed slop right on Belmar at 33 and a half. Okay, so you got all those factors coming in. It creates a very difficult environment. Your forecaster, whether it's me, someone on the news, the National Weather Service, they are dealing with one of the most difficult areas in the world to forecast for. And I'm not just saying that because I live here. It's a documented fact. It's very difficult to handle the forecasting around here, which is why I love it, because I love the challenge. And thank you, Amanda. I really appreciate it. Let's see here. Matthew Myers asks, what are temperatures looking like for November? I think that November is the first week of November. I think is going to start out warm and above normal. But I think from November 15th through the end of the month, I think we're going to trend below normal, and it'll be gradual. It'll be a step down, because what we're going to be doing is stepping down to winter. So you'll be above normal, near normal, then below normal, basically towards Thanksgiving. So, oh, wow, it's almost 9 o'clock. Look at that. Plus the Great Lakes as well. Great Lakes are difficult, but basically you have one environment there. You have the lake effect snowfall, which is difficult to forecast for, but not impossible. And you have the introduction of 1 to 3 air masses. You got air mass coming in from the Gulf Coast via the Tennessee River Valley and Ohio River Valley, and you have your polar and Arctic air masses. Let's see here. So yeah, like I said in November, definitely it's going to be a month of transition and one where we're going to see that step down. And what I'm going to be watching for towards the end of the month in November is the EVP flux and how that will develop to tell us whether or not I was right about the polar vortex and the interruption and the warping of the polar vortex based on the volcanic impact. So all that month, I'll be watching like a hawk to watch that EV flux and see how that impacts the forecast overall. It's going to be a lot of fun. It's going to be very educational. And again, full on honesty here, it is an environment that we never dealt with before, and one that is going to be very interesting to see how it plays out. Well, it is almost 9 o'clock. Wow, we almost made. We got 2 more minutes. How do you see the IOD factoring into this winter? I think it will be the bellwether in terms of how fast La Nina will weaken. I don't see it having a direct impact on our weather pattern. I know a lot of people like to focus on it. It's kind of like the it thing right now, but I think it's a byproduct. It's not a driver. It's an indicator, but it's not a driver. So I'm not worried about the IOD this year. The La Nina impact is already there. Now it's just a matter of how it evolves going forward. And I think the IOD will be a nice signal for that, but I don't think it's a driver in any way in the forecast. And let's see, I'll take the last question from anyone else in the room, and then we will shut it down for the night. I do want to say I want to thank my wife for putting up with me while I'm writing the winter forecast. I know I've been a pain in the ass.
I love you.
I know you love me, but still, I know I can be a pain in the ass. This forecast, it was one that I really enjoyed writing. I hope you enjoy reading it. I hope you learned something from it. I hope the premium members really enjoy it. Definitely, yes, Paul Cosin is the master of Northeast winter storms. Absolutely. Amazing read. I have that book. It is like the Bible for me during winter storms. I would strongly suggest anyone who's interested in meteorology get that book. But I just want to thank everyone for reading it and understand and taking the time to ingest the data, ingest what I wrote. I hope that you've learned a lot from it. And let's see how the winter plays out. Now, I'll be here with every winter storm and see how it works out. So that's it for tonight. I'm going to finish my coffee before I lose my voice. And as always, I'm going to say, just stay safe out there.